Could the Earth become Venus in the future? September 29, 2019. If Venus had picked up slightly luckier tickets from the cosmic lottery, our solar system could host 2 habitable planets today, according to recent simulations by a group of NASA researchers. Instead, our neighbor is a desolate place, and can give us a terrifying vision of our own future. Could the Earth become Venus in the future? Venus shone without clouds compared to Earth. Traditionally, planetary scientists see Venus' infernal temperatures, carbon dioxide-saturated atmosphere, and frozen crust as the inevitable result of their place in the solar system. Sitting very close to the Sun, the unfortunate planet was doomed from birth to be burned to crispness. In recent years, however, an alternative possibility has cast some shadow on this simple story. Given the right initial conditions, cloud cover could protect Venus from the flood of sunlight and keep it pleasant and moist for billions of years, according to simulations presented last week at a planetary science conference in Switzerland. In this scenario, Venus may have been the first habitable planet in the solar system until some unknown catastrophe smothered it in carbon dioxide. Sound a little too close to home? Although our carbon emissions probably cannot completely fry the Earth in the same way, the transformation of Venus may still have an important moral for humanity. Colin Goldblatt, planetary scientist at the University of Victoria, Canada, said if there was life on Venus, they had only one home, and that home is no longer very good. A tale of two. Venus. What keeps the Earth alive, both biologically and geologically, is the temperature difference between the cold crust and the hot core. Cooler rocks sink and warmer materials rise, rocking up and down in a way that keeps most of the planet's carbon locked in underground rock materials. Venus failed to maintain this cycle, so today its atmosphere overflows with carbon dioxide. The question is why this? According to traditional history, a warm sun quickly evaporated the young planet's oceans in the sky, where they formed a dense, sticky atmosphere that retained the heat received with deadly efficiency. Finally, the surface became as hot as the interior, which ended the earthquakes and other tectonic activities that previously helped Venus let off steam. Without tectonic mixing, says Anthony Del Genio, a researcher at NASA's Goddard Institute for Space Studies and co-author of recent research, the crust has become like rigid lid that only accumulates heat and pressure inside. Warming evaporated oceans caused Venus to explode at the top a few 100 million years ago, according to observations of its youthful, spotless surface. Volcanoes erupted all over the planet, flooding the atmosphere with carbon dioxide, which in turn made the planet the lifeless rock we see today. Or so it was thought. Del Genio says, our simulation shows that this story really doesn't hold up. The team's work, which considered 5 potential varieties of early Venus, raises another possibility. If young Venus were swimming in the water like young Earth, and if tides or collisions with nearby bodies slowed its earlier rotation to major S, which are plausible, but unanswered due to the scarcity of missions on Venus, that planet would have developed clouds, and that would have changed everything. The wavy glow of the cloud cover returns sunlight into space, disrupting the heating process. Del Genio says, even when the sun gets brighter, if you start with a decent amount of water, you get clouds thick enough to keep the planet cool. A cold Venus would have kept in its oceans for perhaps billions of years, according to the group's simulations. This means there is no humid atmosphere, which means that tectonic plates can continue to slide and keep carbon underground. If future polls confirm the assumptions about water and rotation, scientists will need to find a new explanation for why Venus lost its protection. Del Genio speculates that a slap from a rebel planet could have done this, or even a random fluctuation in Venus's internal flows. He says, maybe Venus was just unlucky and something happened at the wrong time. Whatever the cause, once the worldwide volcanic explosions disappeared, which took hundreds of millions of years, the planet's dense envelope of carbon dioxide prevented it from becoming habitable again. Venus, the Earth once and future. Since Venus could have been similar to Earth, there is no reason why the Earth could not one day become like Venus. In fact, a hot and dead Venusian twin is almost certainly the fate of the Earth as the sun continues to shine. Fortunately, we have about 1 billion years to solve this problem. Some have speculated that the gravitational pull of redirected comets could drive Earth away from the sun. But it's hard to hear about a planet dying after a carbon dioxide spill without thinking about the climate crisis, since digging up and burning fossil fuels is pretty much what Venusian volcanoes have done. Here is a rare good news: to unleash the kind of venom's Armageddon that's simmering and concealing, humanity would have to work hard to burn off all available fossil fuel molecules and then some more, increasing the concentration of carbon dioxide in our atmosphere from about 400 parts per million ppm to over tens of thousands. On the other hand, says Goldblatt, it depends on how enthusiastic we are about new fossil fuels. Goldblatt himself previously studied the so-called uncontrolled greenhouse effect, where gas emissions would reach a level high enough to turn all our water into steam. This document concluded that human activity would probably be insufficient to bring us to this particular point of no return, but not that it could never happen. Goldblatt said, "I am not saying that it is easy, but it is not impossible. Still, microbes and cockroaches can breathe easily, knowing that humanity probably cannot permanently destroy Earth's ability to radiate excess heat. Unfortunately for the rest of us, the threshold for human catastrophe and mass extinction is much lower. As with Venus, our final destination may depend on the clouds. If carbon concentrations reach much more than 1,200 ppm, preliminary research suggests, we could lose those fluffy friends clouds and experience double-digit warming. It doesn't evaporate the ocean, but it does annihilate us," says Goldblatt. Of course, climate change would seriously challenge human civilization long before it hit the clouds of the sky. Climate scientists and policymakers hope to keep warming at 1.5 to 2 degrees Celsius, with carbon concentrations below 450 ppm, to maximize society's chances of adapting to a warmer Earth. Although humanity will probably never leave Earth, as Venus, our twin's infernal state serves as a reminder that there are no cosmic guarantees. If we want some degree of stability, we will have to design on our own, or at least work harder to stop testing the limits of the Earth. Goldblatt finished. A planet like ours can go wrong. It's the final lesson because as a globally dominant species we have to take care of our planet.